In this video, we are going to learn how to find common factors. Now, we're going to find the GCF of each expression, and GCF stands for greatest common factor, and then we're going to factor the expression afterwards. So starting here, we have 6n squared plus 9n, and we want to find out what its GCF is. So what is in common between all of the terms? Now, 6 and 9 have a common factor of 3, so 3 is part of the greatest common factor. But we also see that each term has an n variable involved as well. So 3n would be the greatest common factor. So now I'll factor out a 3n, and when I do so, I'm going to divide each term by 3n as I factor it out. So I would think of this as n squared over 3n plus 9n over 3n, giving me 3n times, we have 6 divided by 3, which is 2, n squared divided by n, which is n, 9 over 3, which is 3, and then n over n cancels, giving me 3n times 2n plus 3. Now, for the rest of these examples, you won't see me divide by this factor every single time, but I just want to show you that that's essentially what's happening when you factor out a variable as well. So now let's look at this next example. Every term has a 4 in common. 4 is divisible by 4, 20 is divisible by 4, and 56 is divisible by 4. So 4 would be the common factor. So after I factor out 4, I'm dividing every term by 4, giving me x squared plus 5x minus 56 divided by 4, which is 14. So now I'll go ahead and factor this quadratic, meaning that 4 is still on the outside, but now I'm going to find those two numbers that multiply to negative 14, but then add to 5. And I want the bigger number to be positive, so that when I add them together, they give me a positive 5x. So if I use negative 2 and 7, that's negative 14, and then those add together to give me 5. So my other two factors become x minus 2 and x plus 7. So my total factored form would be 4 times x minus 2 times x plus 7. So that greatest common factor you take out, it always stays out there even as you factor the rest of it. That is one of the factors you'll get at the end. So now the greatest common factor between 7n squared and negative 21 is 7. There's no n in common with all the terms like the first one, and that's okay. So when I factor out 7, I'll be left with n squared minus 3 when I divide by 7 for each of those terms. And now I'm left with n squared minus 3, which you don't see that middle term here. That's because the two numbers, the number they have to add up to is 0, which makes this pretty tough because we have to have a positive and negative of the same number. But unfortunately, the only way to make negative 3 is either negative 1 and 3 or 1 and negative 3. And when I add those together, that gives me 2 and negative 2, which isn't 0 for the missing term. So I cannot factor any further, so I stop there. And I get 7 times n squared minus 3 when I factor that quadratic expression. Now I have 9x squared plus 9x minus 18. All of these are divisible by 9. So our greatest common factor would be 9. And when I factor out 9, I'll be left with x squared plus x minus 8. Oh, not 18, minus 2 when I divide by 9. And now when I'm going to factor this expression, I need two numbers that are going to multiply to negative 2, but then add to an understood 1 there by the x. So I need two numbers that multiply to 2, which I only know that 1 and 2 work. In order to end up with a positive 1, I'm going to make the negative 1, the 1 negative. So when they add together, that gives me a positive 1 for that middle term. So now I'm left with 9 times x minus 1 and x plus 2. So those will be my three factors. And again, 9 is an equal value factor as x minus 1 and x plus 2. So there are three factors to this quadratic expression. And lastly, I have 4x squared plus 8x plus 12, which is common factor is 4. Every term can be divided by it. And I'm left with 4 times x squared plus 2x plus 3. So I'm looking for two numbers now that multiply to 3, but then add to 2. And I can only think of 1 and 3 multiplying to give me 3. But they add together to give me 4, which doesn't work. But the other way I can get a positive 3 is with negative 1 and negative 3. But that also gives me negative 4. So again, just like with our example over here in the bottom left, there doesn't seem to be any way to factor that expression. So my answer remains 4 times x squared plus 2x plus 3. So its two factors would be 4 and x squared plus 2x plus 3. And that is how you find common factors.